ahí está. Madam, can you mute the this one, madam? Kavya, madam. Mute it, madam. Kavya, madam.
ಕಾವ್ಯ ಮೇಡಮ್ ಅಂತವ್ರೆ ಎಂಟಿ ಕಾವ್ಯ ಮೇಡಮ್ ಅಂದ್ರು.
Kavya, madam, can you mute the mic?
Okay, sir. Okay.
Thank you, madam.
Manjuna sir, can you hear me?
Yes, sir, I can hear you. Yes.
Oh, thank you. Sumita madam has joined. Sumita madam, can you hear me?
Sir, you are very much audible.
Yes, sir, I was checking whether Sumita madam has joined or not.
Yeah.
Manoj sir, is it
Yes,
Manoj?
sir. Yes, sir. Yes, sir.
ಇದೇನು ಅವತ್ತೇನು ಗೊತ್ತಿರ್ಲಿಲ್ಲ, ಇವತ್ತು ಗೊತ್ತಾಯ್ತಾ? ಹಲೋ, ಸೌಂಡೇ ಗೊತ್ತಲ್ಲ?
ಸ್ವಾಮಿ ಸರ್,
ಸರ್ ನಮಸ್ಕಾರ ಸರ್.
ಸರ್ ಕೇಳಿಸ್ತಾ ಇದೆ. We can hear you.
ಕೇಳಿಸ್ತಾ ಇದೆ
ಸರ್ ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್?
ಎಸ್ ಸರ್, ಪರ್ಫೆಕ್ಟ್ಲಿ ಕೇಳಿಸ್ತಾ ಇದೆ. ಡೋಂಟ್ ವರಿ.
ಓಕೆ ಸರ್, ಓಕೆ ಸರ್, ಥ್ಯಾಂಕ್ ಯು.
ಸರ್, ಒಂದು 5 minutes. ಓಕೆ, ಲೆಟ್ ಎವ್ರಿವನ್ ಜಾಯಿನ್, ದೆನ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್.
देखिए थल्ले हैंड अभी
Sumita madam, kindly check your audio and video.
Sir?
Please kindly check your audio and video, madam.
Yes, sir.
Sumita madam, am I audible?
Yes, sir. Shall we start, sir?
Audible, sir.
We'll wait for 2 minutes, madam.
Yes,
We'll
sir.
wait for 2 minutes.
Dear all, good evening. Is it audible?
Good evening, sir. Yes,
Yes,
sir,
sir,
you're
it's
audible.
audible, sir.
Yes, good evening. Yes, sir. We are going to start in another 5 minutes. Okay. So please ask other friends to join immediately. As of today, now, almost 90 people are joined. 90 people, I think 85 plus. And see, this is the very important AICTE sponsored online ATAL FDP. So as you know, many of you know the rules. 85% attendance is compulsory, and each session we will post the link that is quiz link, very related to that session. In addition to that, feedback. So both the links we will share in the WhatsApp group. My request, you please kindly take that small test, that is a quiz, and also give your valuable feedback. That is very important. And you know, 85% that is as AICTE is fixed attendance. In addition to that, another important thing is 75% score in the quiz is important. I'm sure definitely we're all faculties, no doubt we'll get it. And the only thing is here, you please make sure attendance, okay, should maintain at least 80 to 85%. So another just few minutes, we're going to start the inauguration. After that, session 1 and session 2 today, very interesting one. We'll start another 3 to 4 minutes. Thank you.
ಬರೋದೇ ಇಲ್ಲ ಫೋನ್ 20 ಸತಿ ಮಾಡಿರೋ ಬರಲ್ಲ.
Sumita madam, can you hear me?
Yes, sir.
Yes, sir.
Sumita madam, can you hear me?
Yes, sir. Am I audible, sir?
Yes, madam. We are going to start, madam. Now start, no problem.
Yes, sir. A very good evening to one and all. Myself, assistant professor in Department of Physics, East Point College of Engineering and Technology. It gives me an immense pleasure to extend a cordial welcome to this one-week online FDP program on organic semiconductors in quantum sensing, the future technologies for battlefield superiority, organized by Department of Basic Sciences, East Point College of Engineering and Technology, Bengaluru. And it is sponsored by All India Council for Technical Education, that is AICTE-ATAL Academy. This FDP is a significant step in providing a platform for academicians, researchers, and industry persons to gain a knowledge and explore innovative technologies that hold immense potential in the areas of electronic materials, sensing devices, and defense applications. If I want to talk about this FDP, this aims to provide participants with in-depth knowledge and emerging perspectives in the field of organic semiconductors and quantum sensing technologies. Of course, this week, over the course of this week, the sessions will be delivered. Am I audible, sir?
Yes,
You're
madam, you're
audible.
audible. Go ahead.
Yes, ma'am.
Yes, sir. Thank you. Over the course of this week, the sessions will be delivered by eminent resource persons, scientists, and industry experts, ensuring a rich blend of theoretical insights and practical applications. This initiative aligns with AICTE-ATAL Academy vision of empowering faculty members and as well as researchers with future-ready skills. On behalf of East Point College of Engineering and Technology, I sincerely thank AICTE, the ATAL Academy, for sponsoring this program and for their continued efforts in strengthening academic excellence and research innovation across the country. As we commence this program, let us embrace this opportunity with curiosity, dedication, and the spirit of innovation. I am confident that the deliberations and the interactions over the coming days will be rewarding and will significantly contribute to our professional growth as well. Now, I take a privilege of inviting Dr. G. Maruti, Professor and HOD of Physics, East Point College of Engineering and Technology, and the co-convener of this FDP to deliver the welcome address. Sir, please.
Thank you, madam. Yeah, good evening to all the participants, the dignitaries who have joined this prestigious FDP program sponsored by AICTE-ATAL Academy. At the outset, I would like to invite the patrons of today's program, Srimati L. Ramadevi Venkatpati Madam, the chairperson of East Point Group of Institution as well as MG Charitable Trust. I also welcome Mr. Pramod Gowda, the CEO and the trustee of MG Charitable Trust and East Point Group of Institutions. I welcome Mr. Rajiv Gowda, the CEO as well as the trustee of MG Charitable Trust and East Point Group of Institutions in their absence here. I'd like to welcome our beloved principal, Dr. Pradeep Kumar Dixit sir, for this FDP program. Dr. Pradeep Kumar Dixit sir is an eminent administrator as well as academician. Though he is in the administrative post now, but basically is a very good researcher who has executed many of the live projects of DRDO, especially of ISRO. So on behalf of all the participants and on behalf of the Basic Science Department, I welcome you, sir.
Thank you.
Thank you, sir. I also welcome the academic director, Professor Ashok Herur, sir, who is having more than 40 years of experience in the industry as well as in the academics. And, you know, as usual, he struck out the traffic in Bangalore. I think he is not able to join. In a few minutes, he is going to join. But anyway, I am welcoming on behalf of all the participants. Thank you, Ashok, sir. I also welcome our Vice Principal, Dr. Yogesh, who is also heading Electronics and Communication Department at our East Point College of Engineering and Technology. Dr. Yogesh, sir. Okay. I think he's going to join.
Thank you, sir. Thank you, sir.
Oh, thank you. Thank you. Thank you, sir. I also welcome Dr. Manjunath, Professor and HOD, Department of Chemistry at East Point College of Engineering and Technology, who is the convener of this ATAL FDP program. Dr. Manjunath, sir, I welcome you on behalf of all the participants and our Basic Science Department.
Thank you, sir. Thank you very much.
I welcome all the HODs, faculty members, and other participants, okay, from our East Point College of Engineering and Technology. Very importantly, I welcome all the participants, the professor, the academicians, the industry persons from different colleges, industries, different universities across the country. On behalf of our East Point College of Engineering and Technology and on behalf of our Basic Science Department, as well as on my personal behalf, I welcome all the participants from different colleges and universities. To give a brief introduction about our East Point College of Engineering and Technology, our East Point College of Engineering and Technology is the flagship institution of our East Point Group of Institution, which was established in the year 1999 under the leadership of our late Dr. S.M. Venkatpati sir. with the intake of 180 students in computer science, electronics and communication, and mechanical engineering department. Today we have around 13 institutions with 65 courses. We have around 8,000 plus students in the campus, including the school, pre-university classes, the degree, East Point College of Nursing, East Point School of Nursing, East Point School of Pharmacy, East Point College of Higher Education, very importantly, East Point College of Medical Sciences and Research Center. And apart from this, we are also having 1,000-bedded super specialty hospital in the same campus, which is serving many of the patients at free of cost, especially the people who are living in the rural areas of Bangalore, as well as the people from the Kolar district. This is about the brief introduction of East Point Group of Institution. Now, with this, I would like to conclude by welcoming all the participants. Now, I request Sumita Madam to take over. Thank you, one and all.
Thank you, sir, for your warm words of welcome. And as a co-convener of this FDP and the head of Department of Physics at East Point College of Engineering and Technology, your guidance and supports are invaluable. On behalf of us, I extend a special welcome to you as well, sir.
Thank you, madam.
It is now my honor to invite our respected principal, sir, Dr. Pradeep Kumar Dikshit, to address the participants and share his thoughts on the significance of this program. Sir, may I request you to kindly deliver your address?
Yeah. Thank you. Good evening, all. Seeking the divine blessings of our founder chairman, Dr. S. M. Venkatapati, sir, I take this opportunity to welcome you all once again to the online AICT training and learning, that is ATAL Faculty Development Program on organic semiconductors in quantum sensing and artificial intelligence, future technologies for battlefield superiority. Organized by Departments of Chemistry and Physics of East Point College of Engineering Technology, Bangalore, from 8th to 24 September 2025. I congratulate Dr. Manjunath, HOD Chemistry, Dr. Maruti, HOD Physics, and their team for organizing this FDP. As already it is mentioned by our one of the faculty, 13 eminent personalities from academia, industry, and R&D centers are delivering the sessions in this FDP. I request all the participants to make use of this opportunity in a better way. I wish the FDP a grand success. Before concluding, I would like to tell recently in the month of September 2025, India successfully unveiled its first
Excuse me, sir.
Sir, it is not audible, sir.
Yes, sir. Pradeep, sir. It's not muted, but you're not audible.
Yeah.
I think it has disconnected, Pradeep, sir.
I think he's disconnected. He'll back. I'll inform you, sir.
genius Sangeeta.
Yes, sir, it is audible,
Yes.
sir.
Yes, sir.
Yeah, you can
Yes.
continue.
Yes, sir. Yes, sir. Thank you.
Yes, sir.
Thank you, sir.
Thank you, sir. Next, I have a pleasure if Ashok Herur, sir, is available in the online. Ashok Herur, sir.
I think sir has not yet joined, madam. Once if you join, we'll
Okay.
welcome him and ask him. You can go ahead, madam.
Okay. Now, to conclude this inaugural session, I propose a vote of thanks and express our gratitude to who have made this program possible. On behalf of East Point College of Engineering and Technology, it's my privilege to deliver the vote of thanks for this inauguration session for 1 week online FDP on organic semiconductors in quantum sensing, the future technologies for battlefield superiority. First and foremost, I express our deep sense of gratitude to our esteemed patrons for their constant encouragement and guidance in all our academic endeavors. I extend my heartfelt thanks to our respected principal, sir, and Vice Principal Sir Dr. Yogesh SV for their leadership and support in making this FDP a reality. A special gratitude to Dr. Ashok Herio Sir, Academic Director EPGE for gracing this, in his absence here. I also take this opportunity to thank our co-convener Dr. Manjunath M and co-convener Dr. G. Maruti for their tireless efforts and meticulous planning on organizing this program. A very special word of thanks goes to all the department HODs of various disciplines for their cooperation and encouragement. Your presence and supports are invaluable to us. I would also like to take this moment to express our deep gratitude to all the faculty members of Department of Basic Sciences for their active involvement and continuous support in making this program a success. Finally, I extend a warm thank you to all the faculty participants, research scholars and industry professionals who has joined us. Your active involvement is what makes this program meaningful and successful. With these words of gratitude, we look forward to a week of enriching discussions, fruitful learning, and meaningful collaborations. Knowledge becomes meaningful only when it inspires innovation and serves society. With this, we conclude this inauguration session and move ahead to an academic proceedings of the day. I wish you all an intellectually rewarding experience in the days ahead. It's time to begin our first technical sessions of this FDP. To introduce today's distinguished resource person, I am pleased to invite our respected convener of this program and the head of the Department of Chemistry, Dr. Manjunath M. Sir?
Thank you, madam. Thank you very much.
Yes, sir. Thank you, sir.
Right. Thank you, madam. So, good evening, all. On behalf of East Point Group of Institutions and the Department of Basic Science and Humanities, it's my immense pleasure to introduce today's distinguished resource person and my dear friend, Dr. Kottam Nagaraju, for session 1 of our ATAL online FDP on the topic of introduction and novel methods to synthesize organic semiconductors. This is a very important topic. So, Dr. Nagaraj is currently serving as head of the department and associate professor of the chemistry at Ramaya Institute of Technology, Bangalore. He obtained his PhD in physical chemistry from Bangalore University and brings with him more than 25 years of teaching and research experience. His areas of interest include advanced inorganic semiconductors, semiconducting nanomaterials, carbon quantum dots, and different types of nanocomposites for its applications such as wastewater treatment and hydrogen generation and electrochemistry and different types of biosensors. He has an outstanding academic and research record with nearly, we can say, more than 100 publications and 7 patents and 4 book chapters, and he has successfully guided 9 PhD scholars with 3 more under supervision, and mentored several awarding-winning UG and PG projects. Of course, his contribution have earned him prestigious honor, including the Award of Excellence in Teaching and Best Innovative Project Awards. He has also served as a reviewer, guest editor, and expert evaluator for international projects. Sir, we are indeed fortunate to have Dr. Nagaraj with us today, and I'm warmly welcome him to share his expertise and inspire us all. Sir, Dr. Nagaraj, sir.
Yes, sir. Thank you, sir. Thank you for your nice introduction.
Yes,
So
sir.
let me share the PPT.
Yes, sir. Please.
Kottam, Nagaraj Kottam, welcome.
Sir, thank you, sir. Thank you, sir.
Thank you for accepting.
Thank you, sir.
Thank you.
Sir, please
Yeah, you can
enable
share
the
your.
sharing. Yeah, please
You
enable
can share,
this.
sir. You can share it. No problem now. Manoj, can you stop the sharing, Manoj?
Already I stopped, sir. Still
Okay.
it is in the sharing option.
Thank you, sir. Right. Yes, sir. Now we can share it. Yeah.
Sir, is it visible?
Yes, sir. It is
Yes,
visible.
sir, it is visible. Yes, sir, it's visible.
Yes. Yeah. Good evening. So let me thank the organizers. First, the management of East Point College of Engineering and Technology, and the principal, sir, Dr. Pradeep Kumar Dixit, sir, and the organizing departments, Department of Chemistry and Physics, especially Dr. Manjunath, sir, for giving me this opportunity to share about this, as the title was fixed from my side as per the ATAL FDP program. So I could not change any content related to the title. So as the title goes like introduction and novel methods to synthesize organic semiconductors. So I'll start in the same lines, starting from the introduction and some few methods for the synthesis of a simple organic semiconducting molecules, and followed by and their applications in different fields. So at the end, I'm going to conclude with a small work from our group, which we are doing related to the carbon-based semiconducting materials for sensing applications. Yeah, to start with, so organic semiconductors are materials ranging from small molecules to polymers that can transport charge. So I've given few pictures how these organic semiconductor molecules look. And these organic semiconductors are basically carbon-based materials that conduct electricity to a limited extent. That means the conductance lies between metals and insulators. These OCs are used for flexible, lightweight devices like OLED displays and solar cells because of their tunability, simple processing, and mechanical flexibility. So, why these organic semiconductors are more important in sensing technologies? Because of their advantages and applications. As I mentioned, applications especially in display system. So their ability to emit light makes them ideal for flexible and vibrant displays. and also because of their band gap advantage. So, and also we can tune the band gap, or band gap engineering can be done with respect to organic semiconductors or inorganic semiconductors. So that's why they are more they find more applications in solar cells also. And advantage is lightweight and easy to process. And even field effect transistors, that is the OFETs, because of their sensing and flexible properties. The advantages, as I told, they are flexible, lightweight, and chemical tunability, and then cost-effective processing methods. So just to understand the brief evolution of these organic semiconductors over a period. So actually, for all these contents, as I told, so most of the things are taken from the literature. So in 1906, so the first photoconductivity in anthracene was discovered, and the first observation of photoconductivity in an organic compound, that is anthracene, by Pochettino. And then 1950, semiconducting properties of organic materials, that is recognition of semiconducting properties in organic materials, marking the beginning of organic electronics research in 1950s. Then later on in 1980s, commercialization of these molecularly dispersed polymers, especially the polymers with whole transport molecules in insulating polymers as photoreceptors for electrophotography. Then similar next 1987, so first practical OLED device was developed by Chin Wang, Tang, and Steven. Later on in 1989, advancements in organic solar cells, that is a significant progress in organic solar cell technology, demonstrating potential for efficient energy conversion. Then in 1997, actually commercialization of OLEDs. Then after that, around 2000 onwards, even now we are experiencing the use of QLEDs, quantum light emitting diodes. That is how this evolution of organic semiconductors into electronic devices and solar cell applications. So how these organic semiconductors work? So because of their molecular structure, so these, especially these, as we discussed in the first slide, these are simple molecules and polymers. So the polymer term, actually, we immediately think polymer means it is an insulator. So, but the conductivity is introduced or discovered in polymers. So they are called conducting polymers. This is a serendipity discovery. So in polymer, why they are insulators? Because all the electrons are localized. So if delocalization of electrons done by oxidation or doping. So this pi conjugation present in the polymers. So it is an advantage that the electrons can be delocalized by doping or oxidation. So one of the example that we know, that is polyacetylene. It's a very good conducting polymer. Sometimes the polymers conduct equal to metal. So depending on the doping extent or the number of delocalized electrons. So that's basically the structure of these organic semiconductors makes to behave like semiconductors or conductors in the electronic field. Then the charge transport, this delocalization of electrons allows to move along the molecule and transfer between the adjacent molecules. So as I told, semiconducting behavior also, while typically insulators, but organic semiconductors become conductive when charges are injected from electrodes or excited by electromagnetic radiation or even heat or oxidation or doping. So that is how these molecules work, because basically they are carbon-based molecules. But there are some disadvantages like lower charge mobility. So generally organic semiconductors have lower electron mobility compared to their inorganic counterparts. So shorter lifespan, because their operational lifetimes can be shorter than the traditional semiconductors. So these organic semiconductors. So next we'll move on to the synthesis of these organic semiconductors. So here I've kept two simple molecules or the small molecules like pentacene and rubrene. So as we know, pentacene has a flat, rigid molecular structure consisting of 5 linearly fused benzene rings. It's also polyaromatic hydrocarbon, where the planar nature of this pentacene is crucial for its electronic properties, making it widely used in organic-based electronic devices, that is OFETs. So methods of synthesis. So there are many methods available in the literature. So to list, so scientists will try with the different methods and check the yield or the purity of the compound and the feasibility of the synthesis method, right? So dehydrogenation of dihydropentacene. So for this method, the precursors usually benzocyclobutene is reacted with the anthracene 1,4 end oxide, and dehydration by and dehydrogenation, whatever the hydrate form, the hydrate is dehydrated using an acid like HCl or in presence of palladium catalyst, that is dehydrogenation, to proceed to produce pentacene. But the challenge involved in this method is it is a multi-step with poor overall yield. So as I told, they check with the yield and the purity, and methods can be modified and changed. The other method is reduction method, reduction of 6,13 pentas in quinone. It's also Diels-Alder cyclo addition reaction. So in this, the resulting product is reduced often in a single step to avoid unstable intermediates. So powerful reducing agent such as lithium aluminum hydride is used to form pentacene. The benefit of this method is this route offers a high yield, affordable and high purity synthesis method. So like that, so the method can be changed or used as per the convenient. So what we expect the purity or the yield of the molecules. It's just one scheme I have taken from the literature and it is presented here. So how the lithium aluminum hydride catalyst and finally leads to the pentacene. So the percentage of yield. So after synthesis, how this pentacene is used in electronic field, like the organic field effect transistors. So the substrate is silicon. It serves as a gate. That means it is always on and off mechanism. And semiconductor is pentacene. So the size is 30 to 50 nanometer. And of course, the contacting elements all we require in the construction part. And this is how the block diagram, how it is used in the OFET, the pentacene molecule. So this molecule has properties like electrical properties. So that is, it is a p-type semiconductor where holes are the major carriers. So, and high carrier mobility. So it is known for its relatively high charge carrier mobility, which is crucial for electronic device performance. And similarly, the pi conjugation, degradation, that is pentacene is sensitive to oxidation and can degrade upon exposure to air and light. So that is one challenging part in this kind of devices where pentacene is used. So it should not be exposed to air or light. So then optical properties, as I told, light absorption, it generates excitations upon absorbing UV or visible light depending on the band gap suitable to UV light or visible light absorption. So the color, it appears as a deep blue solid with a violet mixture. So the applications, as I told already, organic field effect transistors, it is used as the source. And then OLEDs, it is used in some electronic applications, including OLEDs as a fluorescent functional dye. And even sensing properties, pentacene has sensitivity to its environment mix. It is useful in applications like humidity and other. Okay. So the next simple molecule, what it is rubrene. So it's a novel method for synthesizing crystalline rubrene directly as a thin film using as a single step plasma based process. It was reported in 2020. So just collected from the literature. So rubrene has a central tetrazine backbone. The structure is given. So with 4 phenyl rings attached to the 2 central rings, giving it a molecular structure similar to a tetrazine molecule with 4 rings. And this is how it is used in the device in different stages. This is again the step-by-step how the device is made using rubrene as a source, as an organic semiconductor. Different stages, ITO coated glass substrates and plasma-based synthesis, masking for patterning, and it goes. So as I told, rubrene, again it is a multi-step reaction. Typically, so the starting materials 1,13 triphenyl, 2-propene, 1-ol, which is treated with the chlorinating agent like thionyl fluoride or methyl chloride to form chloroaline intermediates. Okay, so the formation of the molecules in every step. So like formation of chloroaline, then dimerization, then is elimination of HCl, ring closure, then again elimination of HCl, and finally how we lead with the formation of rubrene. So then it comes to the properties, like rubrene is a tetraphenyl derivative of tetrazine, a family of compound known as polycyclic aromatic hydrocarbons. So, and it has applications in OLEDs like chemiluminescence. It acts as a sensitizer in reactions that produce light. It is also used in semiconductor devices, and of course, more of research in that is happening. Polymerization, polymorphism that can form in various structural forms, including single crystals, polycrystalline, amorphous structures. Next is perfluoropentacene functions as it is an N-type organic semiconductor, and its the properties high electron affinity. So mobility, that is exhibits electron mobility in OFETs, and applications again OFETs. It is used as N-type component where electrons plays major role. And then this is another molecule formation of anthraquinone core. So different methods again, reduction to dehydroanthracene dione, introduction of the pentacene core, where the perfluorination, the pentacene dione is fluorinated with the sulfur tetrafluoride, hydrogen fluoride, etc. And finally defluorination. And finally, we will end up with perfluoropentacene. This is another larger molecules where the organic semiconductors which are reported in the literature other than pentacene and rubrene. Then one more molecule property that is poly-3-hexyl thiophene, P3HT. It has properties like organic. It is like organic semiconductor, functions as a p-type semiconductor, and the solubility, the hexyl side chains attached to the thiophene backbone significantly enhances its solubility and regio regularity. As I mentioned, band gap plays very important role in semiconducting material. So P3HT has a fundamental band gap in the visible light spectrum that is 2.14 electron volt. So it shows, so it absorbs most of the visible light. That means it absorbs sunlight effectively for photovoltaic applications. So the stability point compared to some other organic semiconductors, P3HT offers a relatively high stability. So it has been used in applications, especially the photovoltaic applications. So organic, as I told, it is used in organic photovoltaic applications. And it is also used as a e-skin, that is electronic skin. So where electrochromic and tactile sensing properties can be utilized to create color changing, health monitoring, and robotics. So basically these organic molecules what we develop in the laboratories. So with the suitable tuning and understanding their properties and stability and band gap limitations. So they are used in electronic devices in most of the cases, and even sensors also. So bio-integrated devices also, its biocompatibility and ability to form nanostructures make it a candidate for developing advanced biomedical and tissue engineering applications also. That's just sensing biomedical, biomolecules, etc. This is the structure of P3HT. Now, actually, as I told, so our group actually working on inorganic semiconductors, where they can be used for photovoltaic cells or photocatalysis or even sensing of environmentally hazardous molecules or heavy metals and even hydrogen generation. These are the applications we generally use the inorganic semiconductors. The principle is same like any semiconducting materials. When light is irradiated with the compound, so there will be a generation of charge carriers, and these charge carriers will be involved in oxidation and reduction process. So we have developed some advanced inorganic semiconductor like Z-scheme, S-scheme photocatalyst also. So next, carbon-based nanoparticles also. One of my group is working on carbon-based nanoparticles. So among the carbon-based nanoparticles, as we all know, graphene, it is a two-dimensional and it has unique properties and applications in electronic fields and other mechanical related applications. Graphene oxide, so where the functional groups are introduced to hydroxyl or carboxylic groups, epoxy, carbonyl and hydroxyl groups containing. So, and then we know other form of carbon nanoparticle, reduced graphene oxide, where the reduction of oxygen content from the graphene oxide, and the application of each of these carbon-based nanoparticles are well known, like carbon nanotubes, graphene. The other carbon nanostructure is carbon quantum dots. So what we are working and doing, extending the application of carbon quantum dots for some sensing applications. So also this is also called as organic semiconductor only. So, but it is zero-dimensional carbon quantum dots, but they have conducting properties and sensing properties. So as I told, carbon nanoparticles, what carbon dots we are preparing in our lab and studied their applications for medical or sensing applications. They are zero-dimensional. So what exactly carbon dots? It's a class of discrete spherical carbon nanoparticles with size less than 10 nanometer. So unique optical and electronic properties are they are inert to chemicals, aqueous dispersibility. So they have biocompatibility, obviously because they are non-metal based. So non-metal based nanoparticles and the size is less than 10 nanometers. And since it is a carbon, so biocompatibility, low photo bleaching, photo-induced electron transferability it has. So, and even tunable fluorescence emission. So they are highly fluorescent in nature, carbon quantum dots. That property actually makes us to extend the application of these nanoparticles to sensing properties. So the applications of carbon dots are sensors, biomedical, that is bioimaging, biosensors, drug delivery. These are all the applications. And then it is the carbon quantum dots are also extended to photocatalysis, optoelectronics. So basically the carbon quantum dots, like organic semiconductors, the carbon recent, because carbon quantum dots are discovered in 2004. So now, so it's just 2 decades work, and slowly the applications of these carbon quantum dots are studied by the researchers and reported. So how we do synthesis of carbon quantum dots? Basically, we use just natural sources, so kitchen waste. So no chemicals are used during the synthesis of these carbon quantum dots. so especially fruits peels, vegetable peels, or any bio waste. So any just hydrocarbon, we need a just hydrocarbon where the waste which is coming out from our kitchen can be used as a source to produce carbon quantum dots. So just polymerization or carbonization of this hydrocarbon leads to the carbon dots. Okay, so that's why and even with using chemicals also, one can prepare carbon quantum dots. They are chemogenic, and with bio waste, they are biogenic carbon quantum dots. So this is a few examples what I have represented here. And the method what we have used for the synthesis of carbon quantum dots, that is green synthesis method. So it means in this green synthesis is an environmental friendly method followed in chemistry intended to eliminate toxic wastes or reducing energy consumption or eco-friendly. And no chemicals have been used during the synthesis process. And the method is also cost effective. So the method what we have used is a hydrothermal method. The source for developing carbon quantum dots is a beetroot extract. So once you take out the peel from the beetroot, you can crush that and get the extract and subject it into hydrothermal method without adding any chemicals. And the temperature is maintained at 160 degrees Celsius and for 8 hours. So we obtain carbon quantum dots of size less than 10 nanometer. The method is hydrothermal method, and of course the purification and other things we need to follow. The other source we have used for the synthesis of carbon quantum dot is a snake guard peel. And just as I told in the previous method, you have to crush and get the extract and subject it into again hydrothermal. Keep the temperature 180 degrees centigrade for 12 hours. So you will get the carbon quantum dots. So these carbon quantum dots are, of course, we need to characterize. So just start with, we check the UV visible spectra where to check the N2 pi star or carbonyl groups and carbon-carbon groups, carbon double bond carbon groups. And they are highly fluorescent. If you just keep it under light and in dark and light, you can see the difference in the fluorescent behavior. And you can, and we do XRD, X-ray diffraction studies also to check the peak related to carbon quantum dots, and where the broad peak, because it is highly size is less than 10 nanometer. So, and then just to understand the size and the shape of the quantum, as I told, carbon quantum dots are spherical in shape, and the size is less than 10 nanometer. We have got 5.7 nanometer plus or minus 0.07, the size of the carbon quantum dot. So once we confirm the size, and then of course Raman spectra also, any carbon based materials we do Raman spectra. And to check the functional groups present in the carbon quantum dots, we have done FTIR analysis, where what are the types, different functional groups are present, like carbonyl group and CN, Of course, it is aqueous in medium hydroxyl group. So these are the functional groups. And then luminescence, as I told, they are highly fluorescent in nature.
Yes, sir. Please go ahead. Yeah, Nagra sir?
I think Nagra sir has muted, it seems.
Okay.
Nagra sir, I think you have muted, sir. We are not able to hear you.
So this luminescence behavior is characterized by photoluminescence spectroscopy. So they are highly luminescent, the intensity is almost 4000. So at a different excitation wavelengths. So we have checked the luminescence property of these carbon quantum dots. So next, yeah. So this, as I told, these carbon quantum dots can be used as a sensor. So here we have taken one analyte, that is metal, just that is the iron. How you can sense Fe3 plus ion present in the aqueous medium. So just by fluorescence quenching method. So just we take first these carbon quantum dots and check the PL intensity, then add Fe3 plus ion concentration at different concentrations, and there will be a quenching in the intensity. So based on that, we can even the influence of other ions also we have checked. So this particular carbon quantum dots shows the sensing property for Fe3 plus predominantly. This is how the carbon quantum dots combine with the Fe3 plus and reduces the intensity of the in photoluminescence, that fluorescence intensity. So around 0.39 micromolar concentration up to that low concentration. So we have done a range of concentration of Fe3 plus ion to check the sensitivity limit. This is the just predicted mechanism of quenching with the carbon quantum dots Fe3 plus ions. And see, as I told, it is a biocompatibility. Then how to make sure, are the some evidence or some experimental procedure we need to provide. So these are the beans sprouts we just dispersed in CQDs and left it for 48 hours. So if it is if the beans is growing and that the greenish yellow fluorescence with that fluorescence property, also you can see that the carbon quantum dots are absorbed with the bean sprouts. So when they are growing, so that in that plant, that stem, you can see the presence of carbon quantum dots. So even though the carbon quantum dots are absorbed by this plant during growth, there is no harm. Still, it can grow. So that is one test, simple test we have done for toxicity of carbon quantum dots for biological applications. So more details about the next. Actually, we have also extended the carbon quantum dots for photocatalytic and other applications. But so I'm not presenting the complete details. So finally, to acknowledge the RIT, Autonomous Institute of Technology Management principal for their kind encouragement and financial support, and ongoing DST FIST program and VTU research grants, and I also got RIT seed money, and MSRIT Alumni Association now got funded, and Karnataka Science and Technology also funded for my some student projects, and Indian Academy of Sciences to expose my research knowledge, and all my collaborators and my PhD students. So thank you. And so Manjunath sir.
Yes, sir. Yes, yeah. Hello. Hello. Nagaraj sir.
Yes, sir.
1 second. Hold it. Sir, still your session till 8 o'clock, 7:38.
Manjuna sir, it is up to 7:30, right? From 7:30 to 9, we have second session. I think we can unmute the participants and we can leave the session for question and answers. Manjula sir, can you hear me?
Yes, sir. Yes, sir. Yes, yes. I can hear you. Hello. Any questions, participants? And one more thing is we posted in the this one. Quiz link we posted in the group. Okay, just everyone check it. Quiz link.
Sir, I have the question for the speaker.
Yes, sir.
Are you able to hear me, sir? Manjunath, sir?
Yes, sir. I can hear you.
The speaker
Hello.
is online.
Yeah, Nagraj. Nagraj, sir. Nagraj, sir. 1 second, sir. I will connect.
Yes, sir.
Yes, sir. Yes. Few questions.
Nagraj, sir, are you able to hear me? Dr. Nagraj?
Nagraj, sir, is it
Yes.
audible?
Yes, sir. Please go ahead.
Yeah. I have one question for you regarding the quantum dot from the organic material waste or something like that. So normally, whenever you prepare some amorphous carbon will be there along with the quantum dot, nanoparticles, whatever it will be there. So how you differentiate and segregate it during synthesis process? And what is the yield of the synthesis process that you used?
Yes, sir. Actually, these carbon quantum dots exist in liquid form, sir. So, as I showed XRD spectra, so it is a broad peak where it is not completely perfectly crystalline sharp peak. So, of course, there is some amorphous content. So, and these carbon quantum dots, as such, they exist in liquid form. So that is one of the advantage for medical field or in suppose if you want to use it in solid form also we can solidify that content. And other question that you asked, it is yield. Yes, that yield is the biggest issue. So far we have achieved up maximum of 35 to 40%, sir. So yield is an issue in the synthesis process. Hello.
Any other questions from the participant side?
Sir, I have a question.
Yes, please go ahead, sir.
Yeah, sir. Good evening, sir. Nagraj, sir.
Yes, sir, please go ahead.
You studied that toxic biocompatibility of your carbon dots towards the growth of germination.
Yes, sir.
So, what's the role of the quantum dots in the germination, sir?
There is no role of carbon quantum dots in that, sir. Which just we want to make sure that it won't affect the growth of any plant because we cannot directly, we don't, as lack of facility, we don't check on the animals. And we have one thesis where my student did that experiments as anti-cancer properties also. But just in the plant growth, is there any toxicity? Because just carbon quantum dots, are they toxic or not for biological, especially the plant growth or those things, just to check that. There is no role of carbon quantum dot to growth or inhibit the growth. Suppose if it inhibits the growth, then there it may be a toxic. That's what we wanted to understand. So that is the purpose. It won't help for fast growth or nothing. So even though plant absorb these carbon quantum dots during the growth, during the germination, so there is no effect for the germination. That's all we want to check.
Okay. And so one more question. You have shown 10 images
Yes, sir.
of beetroot based carbon dots.
Yes, sir.
And you achieved almost close to 2-3 nanometer size.
5 nanometers, sir.
5
Basically,
nanometers.
carbon quantum dots means we have to get the size below 10 nanometer.
Yeah.
Which is an average particle size, sir.
But those images I couldn't see.
Yeah, because as I told, the yield is an issue. So somehow we for few sources we get like that. There are other sources where we got even better.
No, are they uniformly dispersed, sir?
Yes, sir. Because when we give it for analysis, they just deposit and dry. That time there may be disturbance in the distribution, but when it is in liquid form, they are uniformly distributed.
Okay, just to add, just a suggestion or something.
Sure, sir.
The question to the previous speaker, I mean, what he has asked. If you can check high resolution TEM, that despacing and all.
Yes, sir.
Probably that will corroborate with XRD crystallinity.
Right, sir. Yes, sir. Correct. Right. Thank you for your suggestion.
Thank you, sir. Yeah.
Yeah. Any other questions?
I have one simple question.
Yes, sir. Please, sir.
Among this inorganic quantum dots and organic this carbon quantum dots, which one is more stable and which one you prefer, sir? Because both the materials are used for almost same application.
Yes, sir. Sir, if you're asking me to preference, so yeah, I prefer inorganic quantum dots, sir. But they are not flexible as organic semiconductors. But with respect to stability wise, inorganic semiconductors are more stable. And also tuning the band gap engineering can be done with inorganic semiconductors, as I feel. So, but more of organic semiconductors are also used in applications where, but only the stability issue is one of the concern. But inorganic semiconductors are stable even at high temperatures and other conditions. So it depends, sir, again, what kind of device at what conditions you use and the people.
Okay, but organic quantum dots might be stable, not sir? I'm just talking about quantum dots, not like semiconducting materials and all. Just quantum dots.
Quantum dots are stable, sir. As I told, that yield is an issue again. The purity is thing. So yeah, so that is again some concerning points. Okay. But still, the people have achieved and they are into use also. So
okay.
Yes.
Thank you, sir. Thank you so much.
Hello, sir. Actually, if we want to fabricate a device using these quantum dots,
yes,
how to handle these, sir? In what way we can?
Yeah. Yeah, but actually on a substrate, of course, we need some metal-based substrate on which we can coat this material. Then,
because it will be mostly in the liquid form.
It can be. Even liquid, it can be coated and it will get dry.
Hello.
Some conducting terminals we need to conduct. We have to use some. Hello.
ಕೇಳಿಸ್ತಾ ಇಲ್ಲ ಒಂದು ಸೆಕೆಂಡ್ ಇರು ಅಲ್ಲ ರೀಚ್ ಆದೆ ನಾನು
Sir, can you mute it if you don't mind? Hello. Sir, please requesting to mute, sir. Mute the.
We can deposit and we can use some terminals for conducting purpose, and people have developed this kind of devices.
Yes.
So, but we are just in a laboratory scale. We are to synthesis.
Stability is an issue again, no, sir?
Yeah, of course. Yes, madam. Yeah. So stability, like we need to check about how long the material can retain its intensity, also fluorescence property and stability, because the particles will start growing by absorbing moisture.
Yes.
So all these things are challenging things. But there are reports where these carbon quantum dots for future, definitely they use for high-end applications like especially anti-cancer and even optoelectronics. So the people want to try carbon quantum dots with inorganic materials. So these carbon materials with inorganic materials, they are going to mix and increase the stability point and can be used. So there are recent reports. So,
Yes, sir. Yes. Thank you, sir. Thank you.
Oh, thank you.
Yes. Any other questions from the participant side? So really, it's an interesting session. Quantum dots and also nanomaterials. It is linked to most of the electronic devices, and also in addition to that, even computer science also. So the main heart of the device, of course, everyone knows the battery. The battery materials, either it is made up of nanomaterials or quantum dots. So that's why the efficiency of the quantum dots we can increase, as sir said. I'm sure definitely efficient. The quantum dot synthesis and stability, if increase, definitely the efficiency of the system also we can increase. Anyhow, if no questions means, so we will already posted the link, quiz link in the chat box and also in the WhatsApp group. You please kindly attend the quiz link, and also requested everyone to give the feedback. So based on the quiz and the feedback, so definitely attendance will be taken. That's the reason. Please kindly give the feedback also. After this session, we'll take the feedback. And now 5 minutes, within the 5 minutes, you please kindly submit. After that second session, we will start. Meanwhile, if you have any questions, you ask, okay. Sir, my personal question, Nagar sir, my interest, especially in the research is, can you hear me, sir, Nagar sir?
Please, sir, please.
Yeah. So as you said, inorganic quantum dots, of course, it's more stable compared to organic quantum dots. But nowadays, most of the organic materials, especially organic quantum dots, are used in the smart watches, are used in many other small electronic devices. But what is the reason, sir, actually? But you said stability-wise, I think low stable compared to inorganic quantum dots. But still, we people are using OFT, and still we people are using different types of smart devices. What is the reason, sir?
Yes, sir. So, as I told, the limitation, like the temperature, up to what temperature the device is used, what range of temperatures, and then the duration. See, for example, the inorganic semiconductors are used for solar applications. So, for any solar cells, so now organic solar cells are also developed, but not into commercial level. So if you think in the commercial level, inorganic semiconductors are there. But it is not that only inorganic semiconductors are in application, or as you told, organic semiconductors are there in the small displays like TV displays or watches, what you mentioned. So there,
wrist watches.
yeah. So because there the limit application is limitation, like the temperatures or whatever it is, and the duration, it is all fixed. So after that, either you need to replace the device or like that. But again, as I told, it depends on what kind of device for what applications. So all semiconductors have been used. So stability issues where it is not that much important, and we want that product or the device is used to this temperature only. It will not go beyond that, or it is protected from moisture and other environmental issues, so it can be used. So for a lithium-ion battery, it has its own limitation. That is, it should not be in contact with water. So we are protecting, as long as you protect from water, it is stable. That since it is highly reactive with water, means we are not limited to its application. It is being exploded for batteries applications. But the limitation is we have to mind that it is should not in contact with water like that. So organic semiconductors are used, but how we have to use, all the conditions are given. According to that, we have to use. It's my way of understanding
Yes.
or feelings.
Yes, that is true. Correct. Okay. Yes. Any other questions from the participants? quiz link and also feedback link posted in the group. I request everyone kindly provide your valuable feedback. That's very important. So thank you, sir, Nagaraj sir. Thank you very much for your valuable insights and your research. I know you are really, I think, doing really good. But now I think we got it. How you people are synthesizing, how the quality of the work, really wonderful, sir. We are thankful to you.
Thank you, sir. Actually, I did not put more of my research related content because we do develop, as I told, inorganic semiconductors as S-type and Z-type advanced and chalcogenides, and with carbon quantum dots also. With this inorganic, we made composites and developed for photocatalysis. So I have restricted to the title of the talk. That's why I did not go much about the other than carbon-based semiconducting materials, what we develop in the lab. So thank you for giving this opportunity. So
Sure.
I'm sorry I could not take complete the session.
No, that is wonderful, sir. Wonderful work. And
So-
I'll request, sir, this PPT, many people are asking.
Yes, sir.
In the chat box also, even
Sure,
in
sir.
the group also.
I will
You please
share. I will share, sir.
Yeah, you share it to me so that I'll post to all the
So, and also
participants.
I request any participants are from your side, if anyone is interested in developing carbon quantum dots in laboratories, they can email me. So definitely if they require any suggestion or help in that, definitely we'll do that, sir.
Yes, sir. And you please, okay, you mail your mail ID, sir, in the
Sure, sir.
post it in the group.
Sure.
So that everyone, I think you please check the chat box.
Yes.
I'm sure definitely if any help is required from sir, you please contact
So my
Nagaraj.
email ID is here. So you can just email me. So
yeah,
I will send even more details about the carbon quantum dots if required.
Yeah.
So,
Nagaraju at msrit.edu. You
Yes.
please note down Nagaraju at msrit.edu.
Because it is a very simple technique. Anybody just you need a hydrothermal setup, because that is the only method where we can have control over the morphology. That's why we restricted. Otherwise, also you can just in a beaker also you can conduct this experiment.
Okay.
So,
Any kind of characterization or any
Yes,
type of
yes, sir.
like FTI or XRD,
Sure.
any kind of characterization, you please contact sir. He'll help you. I'm sure it is a wonderful session, sir. Definitely our participants, they'll contact you. Please kindly help us.
Thank you, sir.
Yes. Thank you very much, sir. Right. So next session will start another 2 minutes. Meanwhile, you please complete your feedback and quiz.
What time does the second session will start, sir? As
Madam,
per the
another
schedule?
yes, madam. Another 2-3 minutes, madam. We'll start within 2-3 minutes.
7:30, madam.
Okay,
From
okay, sir.
7:30 to
Thank you.
9.
Yeah.
Dear participants, the quiz link as well as the feedback link, it will be close at 7:30 exactly. So further, the responses will not be collecting.
Good evening, participants. It's a request to everyone. Kindly log in with your complete name so that we can give the attendance in AICTE portal clearly. I see some of the participants have logged in with your phone IDs itself directly. I request, example, I'll give someone has logged in with the name as admin. We don't know who is that. Kindly edit your name there. And someone is logged in with the Vivo V2031. That participant also kindly edit your name there, and VX58R8. And those participants, I request kindly log in with your complete name. If not, your attendance cannot be marked in the AICTE portal, so that your attendance maintenance will get reduced. Kindly edit your names. Thank you.
Good evening, dear participants. The quiz link, the feedback link, which is also shared in the chat box. Please find with the link with the chat box. Thank you.
Yes. So another 3 minutes, we are going to start the next session. Already sir is in there. Varadarajan sir?
Yes, hello, Dr. Moji. Hello, Dr. Moji, participants.
Yes, sir.
Good
Thank
evening
you.
to all.
Yes, sir. We'll start. Okay. Good evening, Dr. Varadarajan sir. Yes. On behalf of Sir East Point Group of Institutions and Department of Basic Science and Humanities, really I'm privileged to introduce today's second session resource person, Dr. Varadarajan sir. And Varadarajan sir is vast experience in the especially quantum computing, and also he did actually graduate and undergraduate and he did PhD in quantum computing, and especially is very good in high performance computing, and well experienced person, especially in the semiconductor domain. And right now, sir is working in team lead in TUS company. Is a famous American company. I am really very thankful to you, sir. We are indeed fortunate to have Varadarajan sir us today, and I warmly welcome him to share his expertise and inspire us. All. Sir, please take the session.
Yes. Okay. So thank you very much for inviting me and having on the panel and giving a nice introduction. Just a small correction. I did my PhD in astrophysics, where I use supercomputers for doing numerical simulations. So quantum computers are yet to come to that level. So as far as quantum computers are concerned, their hardware is grown, their software ecosystem is not that strong yet. And yes, I am right now more focused on working in the domain of high performance computing, where we use AI accelerator cards for deploying several AI ML models. So in fact, that is one of the words in this topic. So so at the outset, let me give you some kind of a conscious bird's eye view. So since I come more from a computational astrophysics domain, when this topic was first offered to me, it was really out of the box, and I will tell you why. So the title is Organic Semiconductors in Quantum Sensing and AI. So these words are very properly placed, okay? And the purpose, why do you want to marry these three different words, working on three different domains at different levels? For the purpose of battlefield superiority. So how I understood the topic is
not visible.
Sir, madam, I'm not yet sharing anything. I'm just, conveying my idea, but anyway, I will start sharing my screen. So let me know once you see the screen. I just want to first, give a conscious overview. So yeah, what I was telling is there are three different worlds here. One is organic semiconductors, another is quantum sensing, another is AI. You have to bring these three different areas of work for one particular purpose, which is battlefield superiority. So when it comes for India as a nation to stand strong, we should not lag behind in any kind of technology, is my understanding. So certainly these three areas we have to invest a lot and do research, no doubt in that. That's our inner battlefield. And of course, there's an outer battlefield where, given the fact that we are surrounded by different levels of uncertainties due to border issues and other things, these kind of science and technical developments will play a very vital and handy role in protecting us. So I see this as a strategic triangle, okay, or what I call as a silent sentinel. So for the purpose of very strong, impeccable, and undestroyable defense system, we have to use naturally available materials from which we can make carbon-based semiconductors, employ it with quantum sensors, and then use AI models. So when this topic was first given to me, since I'm not directly related to this area, I had to depend on my imagination. So I rendered this image, okay? So I will explain why I'm showing this image to you. So think of this as a futuristic battlefield, okay? The soldier is wearing a gear, right, which is actually very lightweight. So if you look at the equipments used by soldiers in defense, they are very heavy. It cannot be worn easily, and it requires a lot of strength and training. But with these new age materials, these things can be synthesized to be very lightweight, flexible, modular. And being organic, they can be embedded with very different levels of sensing abilities, in turn powered with AI modeled, AI model abilities. So this kind of makes a normal human as like a super cop or a super soldier with amazing powers. So based on this, I would like to drive the talk. As I said, I see this as a sentinel, silent sentinel, the strategic triangle where three different areas come for one purpose. So what is the problem? As India keeps growing, without a doubt, we have a lot of problems coming in from all sides. And these problems are very stealthy. They can't be directly probed with the current technologies. We have several clandestine chemical, biological, radiological, nuclear explosive operations that can act against the country. Added to that, the current devices that is being employed at the level of defense security may have some fundamental physical limits. So the key question is, how are we going to detect these threats, not just by the conventional signatures that have been done so far, but even by its subsidiary, some sort of a subordinate level of a signature, like a faint chemical trial or a minute perturbation in local magnetic field, or how a soldier, before stepping into the other zone, by mistake is not placing leg on a buried IED, or he or she has to find a hidden nuclear facility. So these kind of scenarios we have to imagine, and for these scenarios we have to start preparing ourselves. So my idea is a proposal for a new sensing paradigm. So what I would suggest is to fuse two disruptive technologies. One is quantum mechanics is a very well-grown area of work where several experimental and theoretical evidences exist. So we use that for making ultra-precise measurements of physical phenomena, phenomenological, like based on temperature, radiation, luminosity, magnetic fields. And we enable organic semiconductors based on carbon or other kind of materials for very cheap, flexible, and large-scale sensor deployment. These two, added with a top layer of a brain, which is the artificial intelligence, can be made into, like, one single powerful weapon that could be deployed and cannot be taken down very easily by the opponent. So this is the basic proposal that I had in my mind. Now, the primer, organic semiconductor. This is the hardware, basically the skin. By this time, I'm sure all of you would know that these are carbon-based polymers, small molecules, they conduct electricity, flexible, and all those stuff. The advantages is because of the fact that they are based from naturally available materials, they are flexible and comfortable. They are very low cost and printable. So at this point, I'll make a small deviation. If anyone would have read the book Wings of Fire by Abdul Kalam, there's a place where he says actually for the work he was doing with ISR or DRDO, he had some carbon nanocomposite material, which he actually used for lightening the crutches used by physically challenged children. It made it very light for them and they could move very easily. And he said that was the most happiest moment of his life. So think of that as the most simplest example that could be later scaled for different levels of defense purposes. And of course, it's tunable chemistry. The molecular structure can be engineered to be highly sensitive to specific targets. So this is the hardware, the organic semiconductor. Next comes the quantum sensing, the intermediate software there. So there are several quantum properties which are very unique and cannot be cloned or decohered by external interference. So because of this, the ability to measure these physical quantities with extreme precision is unmatchable. And it is like the base fundamental limit of physics. So if we know how to tap the potential of these devices, we can make, let's say, some sort of a photo detection. Like, for example, you have a faint light coming from opponent side, or you have some sort of perturbations in magnetic fields due to motion of heavy bodies like submarines or torpedoes, or even that there is some controlled explosion somewhere and you have some sort of a long-range thermal mapping. So these things could be advanced using the quantum sensing. So the idea is these sensors, they just don't measure if something is there, they actually get you the exact signature of its existence, because of the fact that the quantum sensing uses properties of quantum mechanics, which is natural at the fundamental level. So now the synergy part. Why organic semiconductor for quantum sensing? Actually, organic semiconductors aren't necessarily the best quantum systems, but they can act as perfect enablers. They provide very low cost, flexible physical platform to host or interface more sensitive quantum elements. And they're very excellent transducers. They can convert a quantum signal into large-scale measurable values. And of course, the functionality, they themselves don't exhibit quantum effects, so they don't interfere with the sensing device. So these OSCs act as a nervous system collecting the signal, the quantum elements are the sensory organs, and AI is the brain. This is then deployed in the hands of a soldier or an efficient army or an air force to get the battlefield superior. So just a vision. Think of a distributed sensor swarm. You can have drone wings that's painted with some sort of a organic material. It's sensitive to magnetic travel, so it can map underground structures. Or like the first image I showed, the soldier can wear it as basically a gear, and then as he or she walks, they can immediately detect traces of agents or radiation that can be very harmful. Or of course, like how you can use it to, like kind of a drop down from a UAV. You can have several OAC-based sensor nodes dispersed over an area and creating a real-time wireless mesh sensor. This acts autonomously. So a human being need not necessarily control it. Given just commands, they can go finish the task and come back without being unaffected. So yeah, at this stage, I would like to show a very small demo. Okay, it's like a practical session. So of course, running a physical quantum sensor is really very complex. So what I do is I simulate a data which is a distributed organic semiconductor sensor network. It will generate and show AI. How can we make sense of it? So give me a moment. So I have written a Python code for it. Okay, so let me do this. So, okay, so here we see a magnetic field comparison. Okay, so the ground truth is actually the hidden tunnel. The red dots are the sensors, and this is what you see as a tunnel. What are the OSC sensors that we deployed on the soldier or some other equipment? They will sense it, but because of them being an organic material with their own defects, right? They will not be able to get the exact value, but they already converge on something very important. So you see certain level of noisy data. Here comes AI, part 2 of the simulation, where the artificial intelligence, based on the data obtained from these sensors, can actually reduce the noise and give you the exact measurement with uncertainty. So, okay, don't worry about the warning. I just had to skip some upper bounds for it. Now, here comes the AI reconstructed image. So, AI, both in the real time and the confidence map in the hands of the soldier device having, right, it will actually show you the exact location of a hidden tunnel or something like that. So this is a very simple example, like a simulation of how organic semiconductors fused with quantum sensors with AI models deployed on it can actually help you predict the uncertainty. So this value here you see actually, right, this is the variance. If you uncertainty, if you take the square root of it, it gives you the variance, which means that the sensor devices should operate not at this level, but more than that level. So this can be used as a calibration based on each attempt and iteration that the soldier has trained to. So your devices are very perfect enough with less error. Okay. Yeah, so yeah, this was the first simulation where we had some sort of 100 low-cost OAC based magnetometer sensors deployed over an area. There was a ground truth tunnel. The idea was to get a slight dip in the magnetic field. We did get realistic noisy data, but then we used AI. For AI, I used a Manhattan kernel. So there are different ways of doing it. People use some sort of Gaussian method and other things, but I used a Manhattan kernel so that it gives a spatial reasoning capabilities. It can interpolate between sensor points and give you exact uncertainty data, and it will help you to denoise it without any external interference. So this is a very simple example of how a real-world AI could assist in an army, a soldier, using these advanced technologies in a very futuristic scenario. Okay. So now what are the results? The essentiality of the results is decision superiority. So the AI successfully denoised the data and clearly identified some sort of a threat. And it also produced a confidence map. So if you remember, I showed you a number. So this is the actual sensor in the rightmost column. So this tells the commander where to send more sensors for better resolution. So the loop is you have sensors with organic semiconductors, you deploy it, you get a noisy data, you use AI, you reconstruct it, you have an actionable intel, and then the army chief or someone will go for resource allocation. And this ODA is some kind of a construct developed in the US Air Force or US Army, is observe, orient, decide, and act. So this entire paradigm that I explained, I would like to put it as an ODA. Observation. The distributed OIC quantum sensor network does the entire observation, orientation. The AI fusion engine will help you to get that real-time data and juxtapose against synthetic information. and make further decision. And finally, decision is recommending the further course of action. Like for example, if you find a very high confidence at a certain location, you know there it is, you deploy the resources and you nullify the thing. Act, like I said, you can direct a soldier or a UAV or anyone for closer inspection. So how a person will work? This OSC with quantum sensing and AI can work either autonomously or deployed as a device with a human being wearing. So this is the most brief idea that I can kind of convey based on what I understood once the topic was offered to me. So now, advances in strategic impact. One, as I said, its cost. It's very cheap. Instead of doing the usual R&D for defense, which is pretty costly, and because of the fact that it can be deployed on a very large scale at a low cost, it is very resilient. There is no losses information, and the opponent side cannot sense these things very easily because of the fact that these kind of front-end semiconductors are using quantum effects, which work at the fundamental limit. If and only if your opponent has that level of advanced technology, they can sense these things. And of course, the ability to scale it in a very large case will ensure that you can easily win the game or a war, whatever it is. Challenges. So the main point is material science. One thing is to have more and more prototypes or successful small scale labs that can operate at different levels, finding these kind of materials and making them very stable and scalable. And then how to integrate them with different kind of devices that work at the fundamental quantum level. And of course, we have AI/ML today, so you can deploy these models. You can train those devices on these AI models to get more better decision-making capacities. So what do I say with this? As I said, it's a marriage of three different fields to create a powerful paradigm for sensing and winning the war. So a battle space is an environment which is very not susceptible to all our plans. It's alive, and it keeps changing very, very quickly. And this kind of futuristic investment can help us to be very powerful in all sectors. So the final call to action is interdisciplinary investment, where you have chemists, physicists, electrical engineers, computer scientists, all working together to achieve this final purpose. So there's a few more I would like to show. I also did some rendering. Wait, let me show. This is so. This is a soldier. I mean, sorry for my very lower graphics. Exposure based on my ability to develop something quickly. I did. So what happens is, in a real time, a soldier will be deployed with this kind of sensors and some kind of a device in his hand, and he'll be wearing some AR-enabled goggles or something like that. That will show his location. What are all the essential parameters that is surrounding him, and then it will keep on sensing the threats around him. But this person cannot be seen as a threat by the opponent because of the abilities that he possesses. This is a OAC quantum sensor network simulation. So what happens is we have deployed a lot of sensors all over, right? They communicate among each other very, very quickly and very efficiently, and very precisely help us to detect a threat. This is done autonomously without the involvement of human beings. Yeah. No, this is another thing for myself. Okay, so really, this is what I have from my side. If people have questions, you can ask, and I would like to very well give some clarification based on my understanding. Thank you.
Yes. Any questions? Any questions from anybody, participants?
So there is a general saying that if there is no question, either I am very clear or I was not at all clear.
Yeah, it's fine, sir. It's very nice presentation. Yeah. Any questions from anybody?
So as I said, I want to take this as some sort of futuristic R&D kind of a scenario. If you look
Yes,
online, you'll get a lot of information for organic semiconductors, quantum sensors. But why do we do them? What is the purpose of bringing them together, and how do we put it? That kind of a scenario, I just tried.
Yes.
Yeah.
Yeah. So, any questions? You please, okay, ask. So quiz link shared in the group. Okay, I requested to everyone you give the quiz. Okay, quiz. I posted in the chat this one session to
Hello.
quiz link. Yes, sir. Yes.
Yeah, actually, you said that.
What is not
Varadarajan, sir?
Very good,
Yes, yeah.
hello.
Yes.
Mr. Prahlad.
Coupling of these three, the AI and then quantum sensing and some organic sensor. You said it's in the battlefield and all. So basically, you're telling that what is the AI what that we use there in the some quantum details.
Sir, I'm afraid your voice is actually breaking a lot. Not able to gather the complete sentence.
Are you able to hear? Are you able to hear?
Yes, now I'm able to hear, sir. Could you please?
Yeah, you said this. What is the quantum tunneling? Basically, it can be used for identifying the tunnels and other things. And you said AI coupled with this quantum sensing plus the organic sensors will be very good for management systems and all that. So, what that AI using AI and all?
Sir, I'm not sure I really understood. You're asking me how AI is going to work there, or like?
No, for this quantum sensors and coupled with AI, then becomes a very powerful tool in the battle. So what is it? I didn't get that part. What?
Oh, okay, I see. So see, what happens is that when you say artificial intelligence, right? It works exactly converse to the human intuition. Okay, in human intuition, you have an input, you have a set of actions, and you have an output. In AI, you have an input, you have an output. You use the algorithm actually to find the intermediate steps that has gone through. So what AI can do is, where human beings are not able to come across an immediate correlation in the pattern, right? These AI models can do it somewhat pretty quickly, especially the deep learning models. So let me put it this way. So take like this. If I give you 100 big prime numbers and ask them to factorize them very quickly, right? Sorry, if you get 100 big numbers and factorize them into two primes, it will be very difficult for you. But if I ask you something from your memory, you can answer it very quickly. Whereas these computers, right, they are the reverse. They can do this heavy computing very easily, but making a data correlation is difficult. But now we have reached that area where computers are coupled with their ability to compute as well as make decisions. And it is being tested pretty well, especially in the commercial domain, which I see. Their failure rate is becoming less and less. So with advanced neural network models, you will have a particular scenario where human being who cannot make an immediate decision based on his bias, his physical strength, his mental strength, this AI, which is not a live being, can quickly sense the data and make some sort of a correlation out of it and help to make a decision. That decision is done based on the confidence level, which in turn is given by the AI models.
Okay. Got it. Okay.
Any other questions? Sir, what is the, my question here, quantum technology nowadays, everyone talking about quantum technology, quantum materials. So normally quantum technology, how it is different from normal technology? And why it is nowadays not common actually?
I would say not common, but I would say there are prototypes. Okay. The reason why I say it's prototype is because these devices work in a limit that is very close to how nature thinks at the microscopic level. Okay. And this cannot be ported and scaled on an industrial basis. Okay. So I can manufacture 100 laptops and sell it in a year, but you cannot manufacture 100 quantum computers and sell it. Why? Because first of all, to maintain these quantum computers not from decohering from its environment itself is an open challenge. Another thing is their fidelity, because in quantum mechanics, the moment you make a measurement, right, the state of the material that was in superposition of several other states will collapse to one value. And you cannot reconstruct it back again in a finite time, in finite possible ways. But this is what makes it very unique. Because of this ability, it can do certain tasks which cannot be done at the classical level. So nature somehow very cleverly demarcates how it applies its rules at the microscopic level and the macroscopic level. So it is because of this very nature of how things work at the microscopic level phenomenologically, we are not able to conduct ourselves in a very quick manner where you can get a working material and then quickly deploy. They come with their own natural properties which we cannot meddle with. Like for example, spin of an electron. Now I cannot put my hand in something to make a spin of an electron to change. I will need an electric field. To generate an electric field, I will need another material. So you see, the prototype itself becomes too costly to maintain. So, but I would say days are not far. We are making pretty good progress, and maybe another half or 1 century, we'll be seeing very interesting devices, which was once in sci-fi movies, but it will be working very well.
Okay. And see, quantum technology, how it is useful in medical fields are actually.
Oh, sorry, good question. If you see the current devices, right, take a pacemaker, okay? If you have a pacemaker and if it is installed in a person's heart, right, there is a particular resistance level it has to operate in, okay? And if that resistance level is by mistake smudged because of many reasons, right, the amount of current going will change and resistance will become very high. The person will begin to choke, okay? But if you have a device that relies on some quantum properties, right, these quantum properties won't interact very easily with other things as long as they themselves are forced to take a state. So they will maintain their sanity, and it will be very helpful to have a very stable device. And also making certain measurements in the human body, which are happening at a very minute level, can't be captured by classical devices. But it will be done with a very massive care, and a lot of regulations will be involved, because even by mistake something happens, it can cost one's life. So I think that's why they have not gone too far. But one area where I see this can have immediate impact is brain-computer interface. So if you see BCA devices already available in market, you just need to wear a gear in your head, and you can control many things around you. Like for example, you can look at a TV screen and you can make a channel change. These things are already happening. These devices implicitly use quantum mechanical process happening in your brain, but still the device works in a classical limit. When that device itself goes to that level where it uses quantum mechanical properties, right? It's like having a superpower sitting on the top of your head. Like for example, a Neuralink chip put inside your brain, right? People who could not walk have started walking now. And now if the chip, which is already operating at certain nanometers, when it starts getting even close to the level of an atom, I mean, you're literally using the power given by nature to power yourself. So yeah, it would be very interesting. But as I said, a lot of R&D needs to take place, and there are pretty large groups around the world. The MIT Media Lab, other things, they are investing in these things and doing very research in the forefront. I'm not sure how about in India, but at least in the defense sector, I'm pretty sure government would be investing in these things. But in normal sense, I'm not sure how much it's popular in India.
Okay. And sir, this quantum technology, because our group, many of our computer science faculties are there, chemistry, physics, and mathematics and electronics. See, in your company, TVS, it's a purely semiconductor company, right, sir?
Oh, no, sir. It's the other way around. So semiconductor is one of the verticals we serve.
Okay.
That too depends on the client. So we are a service-based sector. Depending on the work the client gives, we will have to do, and the work will not be at the scientific level. Though some clients may have their own R&D, they may not give those tasks to us. So ours will be on working on devices that are already manufactured. R&D for the devices, I don't know. UST maybe has its own hardware lab where they do have certain patents, but I have not worked there.
How material science, actually, materials and material science, it is useful for quantum computing, sir. Materials, particularly, see, different types of materials, because your application oriented, okay, company-wise, you can take, they'll see only more application oriented concepts. But we people are synthesized materials, and how we can connect. So materials and quantum technology.
That's actually the very basics, and it's not the connect. You see, for example, think of a quantum computer. There are different kinds of quantum computers. Something uses superconductors, okay, Josephson circuits. But you need a very huge refrigerator to maintain it. Imagine you have a room temperature superconductor, and you can still do Josephson circuit. Then you have a quantum computer working in room temperature. Or think of wireless power transfer for long range power transfer, right? You may need a certain material that can absorb these powerful radiations coming in and convert into electricity. So it's not connected. It is a very basic, but the question is, what is the starting budget? For example, what kind of material you want to synthesize, and for what, that needs to be very clearly defined in the initial stages. Do you want it for the sake of computing? Do you want it for the sake of operating in an industry? Accordingly, the kind of the materials, the kind of properties that needs to be taken care of will change. So there is no exact answer to this question at this moment, but I would say that's the basic fundamental. You need a material on which the entire thing can actually work. So yeah.
Okay, that's good, really good. Because many people are wondering, quantum computing is just emerging technology nowadays. And even government of India also investing a lot of money.
Yes,
even Karnataka, they're planning to open quantum subject.
Professor David Gross was here actually. Professor David Gross, one of the Nobel laureates, was here for the quantum session, and he was telling that not just make in India, you invent in India, then only you can. So he was actually inspiring us. So that was one of his ideas. Like for example, let us say you come up with a very interesting synthetic material that in room temperature can do. I'll give you a very simple hypothetical example. Let's say you have foldable laptops. Okay, like you have a material with which you can make a laptop, but it can be folded like a cloth. It's possible. Now it sounds very crazy, but it can happen in the future. Or you have a particular attire which may not get stained at all, and you don't need to wash it at all. But then this is the point. The product that you're finally envisioning will in turn change the motivation of what kind of material you want to synthesize and how much of labor and industry will it be.
Okay. Yes. That's nice. Really, okay. Very nice session. Any other questions from participants?
Sir, good evening, sir. This is Professor Maruti from East Point College.
Hello, Professor.
Sir, actually, in this organic semiconductors, it is because of the electronic waste, this concept of organic semiconductors came up because this organic material will undergo decomposition, right, sir?
Yes,
right now, is there any company who is using this organic semiconductors for making any electronic devices, sir?
Sir, I think let me quickly have a look at my slide. I didn't tell the company, but I think there is. You have this flexible screens, OLEDs, right? These things are actually, these are somewhat based on that. And I think there is some company in Australia somewhere where they have made a transparent solar panel. Just wait. Let me quickly bring it up for you.
Okay, but generally this organic material will be, it will not be having so much of mechanical strength like inorganic silicon and germanium, right, sir?
True.
Yeah,
that's why they are flexible.
Yeah.
How do they can? Sorry.
How do they overcome that?
System feedback.
Okay, so yeah, to answer your question, right, to overcome that, what they do is they may add certain kind of agreeable impurities that will give a minor amount of strength. But at this moment, I don't think it can be made as strong as what an inorganic material would give. But at the same time, they will limit the purpose to which these kind of materials could be used.
Okay. Fine, sir. Thank you.
Any other questions, sir? Many people are asking, requesting your PPT. You please kindly share the PPT, because of many faculties are from computer science background. They knows very well about algorithms, They're asking, I think last slide you shown, I don't know. I am a purely chemistry guy, sir. I don't know. But maybe I think they're asking your okay PPT, sir. I think algorithms are very interesting. They're posting. Yes, I'm sure definitely it is a useful session for all computer science and electronics and our participants. And in addition to that, yes, if you have any doubts or any queries, feel free. Okay, you please ask the questions.
Yeah, I sent my PPT, the Python codes, and the GIFs to you. I
Yes,
hope
sir.
it helps.
And one more thing, sir. Actually, if our participants sometimes okay hesitate to ask the questions, but sometimes they will. Yes, madam. Uma, madam. Yes, please mute it. Yes, they will hesitate to ask the questions. I know. Sometimes they'll mail, sir. Mail you. Please, okay, answer the mail.
Yes, sir.
And, you please post your mail ID, sir. I'll request you to, okay.
I'll put it in the chat actually.
You put it in the chat box, sir?
Yeah, I put it, yeah.
Yes. See, sir, already, okay, yes, shared VARADA987@gmail.com. Varda987@gmail.com. So you please, any questions, you please ask him. I think I'm sure definitely you post it or mail it. Sir will answer. I think any questions, otherwise, okay, we'll end the session.
Okay, sir. Okay. Thank you, sir. Thank you for having me.
Thank you. Thank you very much, sir.
Yeah.
So yes, participant, thank you very much. Now we posted quiz link and we shared okay feedback link also for this session. I'll request you once again. Tomorrow we have to mark the attendance. That's the reason. Please, okay, come with your proper names. For attendance for us is very useful. Yes, thank you, sir. Thank you very much. You please provide. I posted even the okay mail ID in the online ATAL FDP okay WhatsApp group.
Sure, sir. Yeah.
Posted. This is really interesting session, sir. Quantum okay computing. We are very thankful to you, sir.
It's my pleasure.
Any questions or Manoj? Manoj.
Yes, sir.
You please posted the okay posted right quiz and
I said
feedback.
it. I think just a minute, sir. I'll share it. The chat box also. The feedback form.
No, chat
Yeah,
box and also
feedback link has been shared, Mr. Manjunath.
Yeah, I think feedback is okay shared. Quiz link.
Yeah, feedback link has come, but I think this questionnaire has to come.
For the second session, that will share those.
Yes, sir.
Sir, for second seconds, no, this will feedback link and then quiz link, sir. Kindly just share, sir.
Yes, sir. Yes, I'll share it once again.
I'll share the second the feedback link.
So second one, quiz link I posted, sir. Quiz link, okay.
Quiz link has not been shared.
Quiz link shared in the group WhatsApp.
Only feedback.
No. Just now I shared in the WhatsApp group quiz link.
Mobile kodapakanda.
Everyone got quiz link, right?
Sir, I think there is a issue in the link. I will just share it in 5 to 10 minutes, sir. Within 5 to 10 minutes in the
Sir,
group.
the link which is shared, I guess so it is session 1 link, sir.
Yes,
It is
yes,
for
same.
session 1,
I
yes.
have already responded.
Yes, sir. Even I checked it. We'll share it by 5 to 10 minutes.
Okay,
sir.
okay, okay, madam. Okay, bye.
Can we leave this
Yes,
call
yes,
or
yes, true,
need
madam.
to wait?
The feedback.
Can you add me into the WhatsApp group? I didn't get into the WhatsApp group thing.
I will add, sir. Sir, I will add. Yes.
Sir, dear participants, the feedback link for the second session is shared in the chat box. Please access with that.
Yes, for tomorrow session, again, okay, 6 o'clock tomorrow. There's a 2 important sessions tomorrow also. I think, no, I posted it. First session, I think that is by Vishwanath. He's a professor at HOD MSRIT. Is a very interesting session. And second thing is second session by again see first session flexible and advanced materials. One second. Yeah, first session title is flexible and printed organic electronics for tactical system. Tomorrow 6 o'clock by Dr. Vishwanath Tasila. Is a professor and HOD, Department of Electronics and Telecommunication, MSRIT Bangalore. There's a first session from 6 to 7:30. Again, 7:30 to 9 o'clock. So, advanced organic materials in quantum and AI devices. That is Mr. Dr. Dinesh Murugan is a team leader in TST, okay, Global Technology, Bangalore. It's a US-based company. So these are the 2 important sessions tomorrow. So again, I'll requesting all participants, you please kindly provide your feedback. That's very important. And quiz. So based on the quiz and also feedback, I'll mark attendance in the tomorrow, okay, coordinator, this one, portal. That's the reason I'll request everyone kindly provide feedback and, okay, quiz link. So again, tomorrow, 6 o'clock, once again, we'll post in the group the link, Zoom link, that rescheduled Zoom link, that same link for second session also. So that's why every day we will post, okay, new link. For first session, same link for second session. Please kindly use that. That's very important. And even PPT also we will share in the, okay, mail. Many people, I think, participants are mailed. So PPT we will share you. So I think tomorrow morning I'll share to all the, okay, participants.
Manjunath sir, are we sharing the quiz link now for the second session?
Yes, still sharing. Just another 2 to 3 minutes, sir.
Okay.
Dear participants, if anybody is not joined in the WhatsApp group, so mainly access with the chat box, which I shared with the invitation link for the joining the WhatsApp. Thank you. Sir, Prahalad Rao, sir, please kindly join through this link, the invitation link, sir.
I just now joined.
Yeah.
Let's see.
And
Are you able to see that?
even Dr. Shankar sir also, just I posted in the chat bar, I mean the WhatsApp link. Please kindly join through that invitation link.
Manju sir, shall I leave?
Sir, 1 minute, sir. We'll share the quiz link.
Okay, sir.
Just
Okay. Thank you.
2 seconds. I'll post it in the group.
Sir, sorry for everyone. I think it takes a time, Manjuna sir. I
Okay,
think
ma'am.
it takes 5 to 10 minutes. We'll share it in the WhatsApp, sir, if no problem, if there is no problem.
Yeah, we'll share it in the WhatsApp group, sir. Now, I think I'm very
Okay, sir.
thankful to all.
Thank you.
Ma'am, it is ready. We'll share it, ma'am. Sumita, ma'am.
Okay, ma'am.
Thank you, Manjuna sir.
Shankar sir. Yeah, thank you, sir. Thank you very much. So feedback link will post in the group.
Manjuna sir, thank you.
Yes, sir. Thank you,
It was
sir.
a wonderful session.
Yes, sir. Thank you. Thank you very much, sir.
ಸರ್ ಮಂಜುನಾಥ್ ಸರ್ ಅದು ಯಾವ್ದು ಅನೋಟೇನೇಟ್ ಯಾವ್ದು ಇದೆ ಅದನ್ನ ಇದು ಮಾಡಪ್ಪ ಯಾರ್ಯಾರೆಲ್ಲ ಸ್ಟ್ರೈಕ್ ಮಾಡ್ತಾವ್ರೆಲ್ಲ
ಯಾರು ಮಾಡ್ತಾ ಇರಲ್ಲ ಸರ್ ಆ ತರ ಏನು
ಅದೊಂದು ಸ್ವಲ್ಪ ಅದು ಎಲ್ಲೋ ಇದೆ ಅದು ಅಂಟೇನೋ ಏನೋ ಇದೆ ಅದು ಬರುತ್ತೆ ಅದನ್ನ ಡಿಸೇಬಲ್ ಮಾಡಿದ್ರೆ ಇದು ಮಾಡಲ್ಲ ಸುಮ್ಮನೆ ಸ್ಪೀಕರ್ಗೆ ಭಾಳ ಹಿಂಸೆ ಆಗುತ್ತೆ ಅದು
ಓಕೆ ಓಕೆ
ಪ್ಲೀಸ್ ಅದೇನು ಒಂದೇ ಒಂದು ಆಪ್ಷನ್ ಇದೆ ಸರ್ ಅದು
ಎಸ್ ವಿಲ್ ಅದು ನೋಡೋಣ ಸರ್ ವಿಲ್ ವೇಟ್ ದಟ್
ಅದೊಂದು ಸ್ವಲ್ಪ ಮಾಡಿ ದಯವಿಟ್ಟು
Now everyone you can leave. Okay, I think already posted Google forum in the chat box. One second, sir. Yeah, see quiz link posted in the group. You please check the quiz link and feedback.
Sir, one small suggestion, sir. For the Google Forms, they can make the option for limit to one response.
Yes, madam. That's the one response only, madam.
Yeah, for it was there for the session 1 link. And session 2, I think you may get multiple responses from one email ID.
Oh, is it, madam? I
If it
think
is
that
limited,
will
yeah, if it
restrict.
is limited, it will be really good, sir.
Yes,
Yes,
madam.
ma'am.
That is limited. Yeah.
Thank
yeah.
you so much.
I think in first session, I think only one response. Correct, madam?
Yeah, sir. First session was good. Like first session, they have kept the Google form for limited to only one response from one mail ID.
Yeah, actually,
Second session, it kept open.
we posted, madam. Second, someone deleted. That reason again we posting thing once again.
Okay, sir. If it is limited to one response, like even for
Yes.
you, it would be good, sir, while filtering.
Yes, that's true, madam. That's true.
Thank you so much.
Okay. Thank you, madam. Tomorrow, same time, at 6 o'clock, everyone should join. Okay. Request you because the attendance is mandatory, and that's the reason.
ಸರ್
ಸರ್ ಬಂತಾ ಕ್ವಿಜ್ ಲಿಂಕ್
ಬಂತು ಎಲ್ಲ ಆಯ್ತು 2 ಮಾಡ್ಬಿಟ್ಟೆ
yes sir
ಎರಡು ಆಯ್ತು
it's
Sir, we'll wind up the session.
recording right okay.
ಬೇಡ ಓಕೆ ಥ್ಯಾಂಕ್ ಯು ಬಾಯ್
Manjana sir,
sir
we'll wind up the session.
Yes sir, wait still few people are asking few doubts. Okay, we'll see. Okay.
Sure.
We'll continue because still they're giving this one, right? Quiz and okay, feedback. Yes, those who are given feedback, I'll request you and feedback. Those who are submitted and quiz, those who are submitted, you can leave.
Manjunath sir, can you hear me?
Yes, sir, I can hear you.
Okay. So,
yes, sir.
I think most of the participants have submitted the quiz link and also given the feedback. Tomorrow also there will be 2 sessions from 6 to 7:30 and followed by 7:30 to 9 session. So from 6 to 7:30 we have session by Dr. Vishwanath Thalasila from MSRIT. You'll be talking on flexible and printed organic electronics for tactical systems. And most of the faculty members know about Dr. Vishwanath. Is a very accomplished academician. Basically, he was an industry person. He was in Honeywell for more than 15 years and obtained his PhD and also has done his postdoc from one of the reputed university in the Europe, and is going to talk on this flexible and printed organic electronics. And all of us know that this flexible electronics play a very important role in the cell phones, like a flip cell phones, where this LED panels and LCD panels cannot be folded or you cannot wrap it. Whereas this flexible, okay, organic materials can be used for such applications. And also printed organic electronics in the sense, so the size of these devices will be so small that it can be coated like a printing. So of course, it is going to play a very, very important role in the industrial applications. And second thing is about this advanced organic materials in quantum and AI, okay, devices. Of course, in the quantum computing, for designing this quantum logic gates, they use these superconducting materials based on Josephson junctions. This quantum logic gates are designed, and Dr. Dinesh Murugan, who is the senior product manager at UST Global Technology, who is having more than 24 years of experience in the industry, and he happens to be the research scholar of our R&D Center at our East Point College of Engineering and Technology. He is going to talk on advanced organic materials in quantum and AI devices. So, hope our participant will gain a knowledge on this industrial applications of this organic electronic materials. This is our tomorrow's schedule. Dr. Manjunath, anything else is there to convey to our participants?
True. That is true, sir. What said. Actually, Dr. Vishwanath Tashisha is a eminent person. He did, yes, I'm sure. Okay, he did PhD from Netherlands in reputed universities. I think what we discussed okay, about organic electronic research. He said clearly, organic electronics, of course, nowadays, using different types of modern electronic devices. Because of many applications and because of peculiar properties of these organic materials. You know, what are the peculiar properties means? See, sometimes organic compounds, these compounds are lightweight and we can synthesize easily and it is available in the nature. So we are extracting nature from the nature and we are converting that into useful product and which is useful to the society. That's really useful thing. This type of technology, I think many patents he did, Vishwanath sir, and he said most of the organic materials are used in a wearable health monitoring system, you know, flexible sensors and organic transistors, organic photovoltaics, ECG. Nowadays, everyone In India, everyone facing the problem, heart diseases. But using these organic devices with low cost, we can monitor the ECG and heart rate, etc. in hospitals. Likewise, brain activity and blood oxygen system, sweat composition, within fraction of the seconds, we can detect using flexible electronic devices. These devices mainly contains organic materials. And also he said one more interesting point, very important point in drug delivery system. When we were talking with her, he said most of the organic materials can act as biostimulators, and these biostimulators, releases drugs in controlled way. Controlled way. It's very important concept in medical field. And also another important thing is, artificial vision, mainly artificial vision. See, artificial vision means nowadays most of the organic photodiodes can mimic the function of retinal cells present in the human eye. This type of materials we're going to synthesize with the help of organic compounds, because these are flexible, highly flexible and low cost, easily we can synthesize. In addition to that, said very interesting concept in tissue engineering and regeneration. Tissue engineering nowadays is very important concept in medical field. This type of tissue engineering things, conductive organic polymers. We can say conducting organic polymers we're using. And these conducting organic polymers can provide electrical stimulation to help nerves for regeneration. And another important, interesting point is scaffold-coated organic electronics, and these electronics can encourage cell growth in human body. So likewise, he said many advantages and many applications. He's having vast knowledge, especially in organic electronics, used in various organic electronic devices. That's very interesting, of course, interesting session, what we will expect tomorrow. And in addition to that, Dinesh, of course, Dinesh is huge knowledge in quantum sensing and AI. And also semiconductor technology. I think is one of the CEO in US company. I'm sure definitely tomorrow you will expect very good sessions from these two resource person. Yes, that's true, Marte. Any other questions? And those who are submitted, you can leave the session. And I'm very happy to all the participants, almost 160 plus participants are participated today's session 1 and session 2.
Yeah, Dr. Manjunath. See, we are talking about this technology in the battlefield, right? In the fighter jet, stealth technology is very, very important. That makes a huge impact, in achieving the supremacy in the battlefield. So stealth is basically this radar systems cannot identify these fighter jets, right?
Yes, yes.
Dr. Manjunath, can you hear me?
Yes, yes, I can hear you. I can hear you. Yes.
Okay. So if not electronic material, is there any organic material that can be used to coat this fighter jet, where basically this stealth means when the radio waves fall on it, it will not be reflected, so that radar cannot identify it. Okay. That is the thing. So is there any organic material that can be used to coat this fighter jet, so that which is having a more absorption coefficient of this radio waves, so that it will not be reflected? Can you elaborate on it?
Yeah, exactly. What you said, organic materials, yes, it plays very important role. For example, you can take carbon material. Carbon materials such as graphene and carbon nanotubes and carbon quantum dots. So these are the main important advanced materials nowadays what we are using to coat. In addition with many other different types of chemicals we are using to coat on the surface of aircraft. So these materials, it will absorb completely. We can say 95%, okay, it will absorb radio waves and remaining only very negligible amount of, okay, light, or we can say radiations, it will reflect back. Example, in addition to that carbon materials, we are using conducting polymers such as polypyrrole and polyaniline. So these polyaniline and polypyrrole having backbone, that means pi electron system. These pi electrons, okay, system absorbs completely electromagnetic waves. This results, you can't detect where exactly the, okay, aircraft is coming from, the, okay, enemy side. That's very difficult to detect. That's why these are the main important organic materials we are using to coat on the surface of aircraft. And the main important here advantages why we are using this type of material in the nature. Many number of, okay, organic compounds are there. Why we are using only carbon and carbon related compounds? These compounds are synthesizing point is very simple, very easy to synthesize, low cost, and these materials are lightweight, highly flexible, and these materials, it will mix with different types of solvents, so that it's very easy to coat on the surface of aircraft. That's the reason this type of materials are extensively used in stealth technology.
Sir, added to that, I have a couple of questions with you. Can I?
Yes, 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 sir.
You're talking about carbon nanotubes as well as darts. So what about their the sustainability? Because nanotechnology, how do you sustain? I mean, it makes a sustainable the environment.
See, there is a drawback.
I mean, it's not a biodegradable component, no?
No. That is not like that. See, almost all carbon compounds are not biodegradable. Example, you can take starch. Starch is made up of carbon. That means carbohydrate. Nowadays, starch bags we can degrade very quickly. When you go for polythene bags, even polythene bag also made up of carbon and hydrogen, but it is not biodegradable.
Yes.
Even if you put it in the soil, after 50 years also, you can see in the same form, it won't degrade.
Yes.
Starch bag within 1 week, we can degrade. So likewise here also, for example, you can take carbon dots and carbon compounds such as carbon nanotubes, and there is a few limitations. What are the few limitations? Session 1, sir said, I think Nagra said, one is temperature. See, if we increase the temperature, automatically these compounds, it will evaporate. These compounds, it will evaporate. That is the reason these compounds mix a dissolved suitable solvent, suitable material. We can make complex material. That complex compound we are using to coat on the surface of aircrafts.
Yeah, that is fine. Coating the aircraft or designing any, I mean, the coating any the surfaces to make a shine and I mean the it will tolerate the wear and test the threshold. But finally it has to be eco. The product has to be come to the eco, right?
That's
so that
true.
is a high priority.
Yes.
So that we need to completely take about the care about the environment effects. So what about your thought on that?
Yeah, because see, not like carbon nanotubes and carbon quantum dots and graphene material. Of course, these are, yes, I'm sure definitely these are not like polymers. We can degrade some extent. We can degrade. And we can say these are like friendly elements with the environment. Since you are taking from the environment, most of the environment made up of 90% of carbon, even in the human body also. Okay, human body is made up of 90% carbon. That's the reason you can't say all the carbon compounds are not biodegradable. Many are biodegradable. Example.
They are in the singular component, they are degradable. But you are saying that you are telling that it is the composite materials. If you do mix it with any other materials, then again the chances of it is not suitable for the environment effects. That's what my thought.
True. If that is the case, we can convert one form of the compound. If the compound is not biodegradable, assume carbon compound in plastic is not biodegradable. What is the solution? What is the next solution? See, even in the
That's
Yeah.
we need to have a research on those things.
Yeah.
Because these are facts, so that is, I mean, it is not biodegradable.
Yeah. For example, you take plastic chairs. It's a
Yes.
polymeric material. It is not biodegradable. What
Yes.
we will do if the plastic chairs are broken, or if the plastic materials are okay, use is completely okay. Yes. Then what we have to do? Such type of materials we will collect and we will incinerate. Incinerate means we will heat it at very high temperature.
Yes.
Result, you will get another form of the what we can say polymer. That new form of the polymer we can use for other various applications. We can convert that new form into the another new chair, maybe another plastic material.
This is
So
a
like,
complete recycling process, what you're telling.
yes, exactly, recycling process we will do. That's the only one best method nowadays what we are using to convert waste polymer into the useful polymer. That's the only one option, recycling.
Yeah.
See, for example, you can take
See,
even our computer, laptop.
Dr. Manjunath, I think 2 days back, our Central Transport Minister Gadkari announced that they have made one project near Delhi where they have used only this waste materials, and now they are thinking of collecting this waste material from the dumping yard, and they are recycling it and they are using for laying a roads.
Yeah,
And
yeah.
in fact, the lifespan of that roads will be more than this conventional roads where it will be made out of this tar, right? So, as per their estimation, 6 lakh tons of such waste materials are available in this dumping yards of Bombay, Bangalore, Delhi, Calcutta, like how there are many cities in Bangalore city. From there, they are planning to collect this dumping material and they're recycling it and they're putting it on the tar road so that you can save the this one resources as well as you can increase the lifespan of it, and also it will be very economical. So it's been already experimented it. Mostly it is going to be implemented in down the line and maybe another
Yeah, now
2-3
there is
years. That's
huge demand for the waste management treatment. So
Yes.
there's a huge products for which is evolved for the waste management.
Yeah, true. Because what we are using, see, as Marty said, plastic bottles, plastic materials, these are, we are converting into the tar.
Yes, yes.
We are converting into the tar. So we are using that material to make a road. That's a one good application.
Yes.
Likewise, many things are there. Okay, recycling process. Many things are there. For example, you can take, with the help of plastics, we are generating petrol and diesel. We are generating different types of fuel.
Yes.
So that's because you take any polymer, plastic bottle, anything which is made up of carbon and hydrogen.
Yes.
Even petrol, it contains carbon and hydrogen. So that you can break, for example, petrol contains 10 carbon atoms. Your plastic chair contains some 1,000 carbon atoms. If you break it into small fragments, that is nothing but petrol and diesel, which is used for, of course, in automobiles.
Yeah, that is it.
Many.
So the process of making this, it is not cost effective.
True. There is a cost effective and also not eco-friendly.
Yeah.
For example, while incentering means burning of polymer, releasing huge amount of toxic gases that it will pollute into the environment. That's the reason Pollution Control Board, they made very strict rules. While you're incentering, while you're burning, you should not release even small amount of gas into the environment. That's why nowadays modern technology, even if you burn it, you should not come out even small amount of gas into the environment. That's a one advanced technology nowadays what we are using. Of course, the cost effective is there, but one main important thing is we are not polluting the environment. So that's a major concern.
Okay, but how do you? Is there any the way to overcome from all these kind of difficulties? Like it is not it's not eco-friendly. I mean, we need to make eco-friendly also. That we need to keep it as sustainable also, and it is less cost effective also. Any process has been evaluating.
See, many techniques are there. That's why you said no. That's a cost effective. For example, nowadays there is a plastic bag, starch bag. Starch bag, disadvantages. not that much strength compared to your plastic bag. In between, of course, if you do some research to increase the strength of that starch bag, I'm sure in future you have to expect such type of technology. Otherwise, Bangalore itself, every day we are using some lakhs tons together plastic waste, and we are dumping into the environment. So automatically it won't degrade. And even while converting one form of the plastic into the another form, during that process, releasing huge amount of toxic gases into the environment. That's the reason, of course, in future, we have to do research, and we have to use this type of biodegradable bags, biodegradable, coats, biodegradable, what we can say, different types of, devices. Otherwise, it's no, very difficult.
Or else we need to completely replace it by, organic, the materials. So
Yes.
that's good actually. Organic means maximum, that's not much,
Nowadays, people, they will expect high quality material with low cost.
Yes.
With low cost. Everyone, if you ask, we want good like material with low cost.
Low cost.
So that's the reason. See, fancy bags required. Fancy bags are made up of what? Definitely plastic.
Plastic.
Right?
Because it is one of the cheapest, cheapest one.
Yes. There is no, I think, yes, lot of research is required in that area. I'm sure in future, see, even today, BBMP completely banned the use of some micron, plastic bags. Still, people are using same.
Using.
Because if you go and ask, no, what is the alternative? Can you suggest alternative? We'll use such type of bags. Even they don't know what is the alternative. Those are banned. They don't know what is the alternative. See, by pressure, they ban it. What is the alternative? No one knows.
Because this is an addiction. Addiction is taken. So everybody has been accommodated with the plastic they are using, and they have been strictly followed with the comfortable with the plastic. So still the people are there continuing. But if you look at 10 or 15 years back, so there is no much plastic. So the same you can implement, right? It no.
True, but because of population, because of needs, because of luxury life, everyone want luxurious car. Everyone want luxurious devices. You take any devices nowadays. See how we are depending on polymers. How we are depending on plastics. Without plastics and without polymers, you can't survive. Example: your shoes, plastic. Your chappal, plastic. Your water bottle, plastic. Right. So your electronic device, plastic. Your cell phone cover, plastic. Your laptop, plastic, right? Your TV, plastic. Your automobiles,
this is one possibility. We need to take care about ourselves. So to reduce this plastic or else, usage of this, to make a sustainable environment, we need to take an individual care. So we cannot make it as much comfortable zone. So just have concern about the society and environment. So we need to take care about, avoiding all these things. That's the only one possible way in the recent trends.
Yes, that's true. So anyhow,
actually, this microplastics and nanoplastics have become a big challenge now. Very recently, one report has come in one journal that the people who are living in the coastal areas are prone to cancer because finally every plastic is get into the oceans, and that plastic materials are broken into a micro level and nanoparticle size thing, and it is getting into the underground, and also it is being absorbed by the plants. And when the animals graze that grass, and when we drink the milk of it, so that indirectly this micro and nanoplastics are getting into the human body, and that is leading to cancer actually. So that's why now coastal people are more prone to this cancer diseases than the people who are living in the Deccan area. So therefore now this government is seriously thinking of how to minimize that. So the only way is to ban the plastic, but nowadays all of us know that they can't afford to ban it because now we are in the developing stage. The economy cannot grow without the business, and in this era of business, for everything, for every packing, inevitably they have to use the plastic materials and plastic packages because that is what is that waterproof material. But now the challenge is we have to find some alternate material which is showing a property of plastic, okay, so that which should be a waterproof, but it should be biodegradable. I think some researchers are come out with such materials, okay, made out of starch, okay. I think that is biodegradable. By using such kind of a packing material, to some extent, we can minimize this problem. Dr. Manjunath, can you elaborate on it?
Yes, sir. Yes, I think I got one call. Yes, sir. Tell me, sir. I did not get your question.
No,
Hello.
no. This plastics, no, microplastics and nanoplastics have become a problem now. That is lead to cancer among the people, especially who are staying in the coastal area. Because finally, when we throw a plastic material after usage, after just one usage, finally it will enter into the rivers, during the rainy season, and finally all rivers lead to oceans, no? Therefore, finally all plastics are mixing into the ocean water, and there it is breaking into microparticles and nano plastic particles. And therefore, finally, it is also contaminating the underground water. And when the people consume that underground water, it is directly entering into the human body. So therefore, one research journal has published that the people who are staying in the coastal area are more prone to the cancers than the other regions. So therefore, government is thinking of to minimize the usage of plastic if they cannot completely ban it, right?
Yes.
So therefore, we have to find some alternate material, especially the decomposable organic material, which is having a property of polymers like plastic, which is a waterproof and a flexible material and suitable for packages. And from long time, people are using starch for making such carry bags, right? Mr. Manjunath, are you getting it?
Yes. Yes.
So is there any other organic material, that is biodegradable and cheaper than the starch, and that can be grown with some plants so that it will also help out the farmers? Can you elaborate on it?
Yeah, see, most of the what we can say vegetables are most of the, for example, you can take any type of vegetables, seeds, which contains starch, which contain, you take sunflower seeds, or you take groundnut seeds, or you take maize, anything which mainly contains made up of starch. So starch is very cheap material. With 1 kg cost approximately 60 rupees, right? 60 rupees, even preparation also very simple, but only one drawback is it is completely biodegradable, eco-friendly, but the major drawback is strength. If you use starch to prepare different types of devices, the strength is very low. Then which is the best method to increase the strength? See, starch, or you take any cellulose, it's a layered material or layered structure. In between the layers, if we insert such some type of like metallic thin layer, I'm sure definitely the strength it will go up, and we can minimize the what we can say cost also, and we can increase the eco-friendly also, because once you insert that material itself, when sunlight falls on the material, automatically, semiconductors, when sunlight falls on it, automatically, if the starch contains double bond, it will break the double bond and convert it into single bond and convert it into radicals. In that way, we are breaking the bonds. In that way, we are degrading the material. So such type of technology is required. Even, for example, you take polyethylene. Even polyethylene also, it's a layered material, but it is not biodegradable. The reason is the carbon-carbon bond strength is very high. So in between the, polyaniline, for example, you can take any bottle which is made up of polyaniline. Like it's a layered structure. In between the layer, if you dope semiconducting material, that semiconducting material, what happens now? When plastic bag or plastic bottle, when throw outside, that semiconducting layer absorb the light and degrade plastic into the carbon dioxide and water. Such type of technology is required. I think no one invented this type of technology. For example, plastic bottle, you dump it outside, even after 50 years also, we can see same condition. But in place of that, if you insert some type of semiconducting material, that semiconducting material degrade plastic into carbon dioxide and water. So definitely such type of technology is required. Otherwise, what happens, you're talking about not only that, lakes and rivers, even in Bangalore itself, the drainage also contains different types of, plastic bottles, plastic bags, plastic materials. These plastic materials combines with other type of chemical compounds, it will leach us. The plastic leaches and converted into microplastic. That microplastic easily dissolves in the water. And this type of impure water enters into the boreal water present near the, what we can say that drainage. So enters into the, boreal water. If you're using such type of boreal water, contaminated microplastic boreal water, it will block the kidney and kidney failure and skin diseases, skin cancer. Of course, it's very dangerous. You can see even milk, cow milk contains few milligrams of, microplastics. So that is the condition nowadays, what we are, facing. It's really horrible. Because technology is required, I'm sure it's very difficult. Many research, things are there. It is not marketized, but still it is under research level only. I'm sure in future, we can use such type of gels in drinking water. Of course, it will absorb microplastics. Then it become microplastic free drinking water. Of course, that type of technology is required, but it's many drawbacks are there cost wise, and yes, it's a very difficult actually. Yes, any other clarification, sir?
Dr. Manjunath,
yes, we'll wind it up. So anyhow, we are thankful to AICTE and we are thankful to all the members, participants, and we are thankful to AICTE, Chairman sir, and AICTE members, and for this providing wonderful grant to conduct online FDP. And also we are thankful to the participants, even co-coordinator Maruti and Manoj. I think Manoj did really wonderful, this one.
Yeah, true. Manoj played a very important role today.
Yes.
It's
Thank you very much, Manoj.
Not done anything. So what I know, that only I have done. Thank you for that. At least your recognition. But we're in the institution and we have a colleagues. At least I cannot have a help on this level. So that it is not my
No, you did a wonderful work. Really, Manoj, you did a wonderful work.
Same support I can provide you whatever at any point of time. And thank you for organizing this, and I'm also very thankful to be a part of this the event.
Yes.
So, and you have explained from your and also I have received many concerns, like what I know. I don't know still some of the things whatever there in my mind, I can openly discuss with you also. So you have given the very clarified the answers for that. So it is very satisfactory. Thank you, sir.
Thank you. I think
okay, sir. I think Dr. Manjunath, we can conclude the session for the day.
Yes, we can conclude. Before that, before that, those who are not submitted feedback and quiz, kindly submit. Yeah, you please conclude, sir.
So once again, let us thank the Atal Academy of AICTE for sponsoring this FDP program. And also let us thank our management of East Point College of Engineering and Technology, as well as the principal and the academic director for their continuous support and encouragement for conducting this kind of program, which will enrich the knowledge of the faculty members that can be imparted to the students. So I think we can conclude for the day.
Yes.
Okay, sir. Good night.
Thank you. Good night.
Okay. All the participants are requested to leave the session for the day. We'll meet tomorrow sharp at 6 o'clock. Thank you, one and all. Good night.
Thank you, sir. Good night.
Thank you.
So shall I wind up, sir, the session?
Yes, yes, please.
Yes, sir, you can. Participants Sudha came